The world around us seems to be a complex place. Although there are some simple truths that seem to be eternal, apples always fall to the ground, not to the sky, the sun rises in the east, never in the west, our lives in spite of modern technology are still all too often at the mercy of complicated processes that produce dramatic changes out of the blue. Weather forecasting is still as much an art as a science. Earthquakes and volcanic eruptions strike unpredictably and seemingly at random. Stock market fluctuations continue to produce boom and bust with no obvious pattern to them. From the time of Galileo, science made progress, enormous progress, largely by ignoring these complexities and focusing on the simple questions, looking to explain why apples fall to the ground and why the sun rises in the east. Progress was so spectacular indeed, that by about the middle of the 20th century, all the simple questions had been answered. Concepts such as the general theory of relativity and quantum mechanics explained the overall workings of the universe on the very large and very small scales respectively, while the discovery of the structure of DNA, and the way in which it is copied from generation to generation, made life itself and evolution seem simple at the molecular level. And yet, the complexity of the world at the human level, at the level of life, remained. The most interesting question of all, the question of how life could have emerged from non-life, remained unanswered. It is no surprise that the most complex features of the universe, which proved most reluctant to yield to the traditional methods of scientific investigation, should exist on our scale. Indeed, we may be the most complex things there are in the universe. The reason is that, on smaller scales, entities such as individual atoms behave in a relatively simple way in their one-to-one interactions, and that complicated and interesting things are produced when many atoms are linked together in complicated and interesting ways to make things like people. But this process cannot continue indefinitely, since if more and more atoms are joined together, their total mass increases to the point where gravity crushes all the interesting structure out of existence. An atom, or even a simple molecule like water, is simpler than a human being because it has little internal structure. A star, or the interior of a planet, is simpler than a human being because gravity crushes any structure out of existence. And that is why science can tell us more about the behavior of atoms and the internal workings of the stars than it can about the way people behave.